Dear friends, welcome back to the channel. Today, we will cover central tendency and dispersion in this video, a foundational step in EDA, exploratory data analysis. First, let's take a look at three really common and useful ways to summarize a set of numbers: mean, median, and mode. Let's start with the mean. This is just a fancy word for the average. You take all your numbers, add them up, and divide by how many there are. So for example, we have the numbers 4, 1, and 7. Add them together, 4 plus 1 plus 7 gives us 12. Divide that by 3 and you get a mean of 4. Next up is the median. The one's all about the middle number. You first arrange the numbers in order, so 1, 4 and 7, and then just pick the one that's the center. Here the median is 4. If you had an even number of values, you would take the average of the two middle ones. Finally, we have got the mode. The ones, the most frequent number, the one that shows up the most. Let's say we have the numbers 4, 2, 4, 3, 2, 2. Here the number 2 appears 3 times, more than any other number, so the mode is 2. So just to recap, mean is the average, median is the middle value, mode is the most frequent. Each one gives us a different way to understand our data. Now let's try these examples. You can pause the video here, solve it on your own, and then continue to check the solution. So example 1, 4, 10, 6 and 20. Add them together. 4 plus 10 plus 6 plus 20 gives us 40. Divide by 4, the total number of elements in this set, and you get a mean of 10. To get median of 4, 1, 4 and 7, arrange the numbers in ascending order 1, 4, 4 and 7, and take average of middle numbers as the number of elements in the set is even. So 4 plus 4 gives us 8, divide that by 2 and we get 4. Now example 3, arrange the numbers in ascending order so that you can easily count the occurrence. 2, 2, 4, 4, 4, 7, 7, 7, 7, 8. So 4 appears 3 times, 7 appears 4 times, and answer is 7 as it has the most frequent occurrences. Now let's move to the interesting example. So we have these numbers 10, 15, 15, 20 and 50. So let's calculate the mean first. So 10 plus 15 plus 15 plus 20 plus 50. So that comes around 110. Divide that by 5 and you get 22. So that is mean. Now let's find the median. Since the numbers are already in order, the middle value is 50. So the median is 50. Now think about it. Which one describes the data better? The mean or the median? Clearly, it is the median. Most of the values are close to 50. The 50 is pulling the mean up to 22, but it doesn't represent the central tendency well. Let's take another example to drive this home. Imagine a city with 1000 families. The average or mean monthly income is $10,000. Sounds great, right? People are happy and prosperous in the city. But wait, what if 10 families earn in billions and the other 990 families earn just $2,000 per month? In that case, the mean is misleading. But if you arrange all incomes and pick the middle one, the median would be $2,000. A much more accurate reflection of the typical family's income in this city. So in cases like this, median tells the real story, not the mean. Moving to standard deviation and variance. Let's now talk about standard deviation and variance, two super important concepts when it comes to understanding how spread out our data is. First up, standard deviation. It simply tells us how far the numbers in our dataset are moving away from the average. Think of it like this: the bigger the standard deviation, the more scattered your data points are. Another thing to remember is, if you are measuring heights in meters, the standard deviation will also be in meters. This makes the standard deviation much easier to understand and relate back to the dataset. It gives you a more direct sense of how far, on average, each data point is from the mean. Now, variance is basically the same idea but in squared units. You can think of it as the mathematical twin of standard deviation. It gives us some information about a spread, just in a slightly different form. For instance, if you are measuring heights in meters, the variance would be in meters squared. This makes variance less intuitive to interpret in the context of the original data. It's the average of squared differences from the mean. So for a population of n, values like x1, x2, xt and xn, the variance is sigma x square equals to 1 divided by n, sigma I from 1 to n, xi minus mu square. So where you see sigma square is variance of the entire population, n is the total number of data points in the population, xi is the ith value in the data set, mu is the mean or average of the population, and if you really try to describe the formula, so for every value in the data set, subtract the mean. Okay, this gives you deviation. Square that deviation to make all values positive and emphasize larger deviation. Sum all those squared deviations, divide the total value by n, because we are calculating variance for the full population. This gives us the average of the squared deviation from the mean. That's the population variance. So let's take a quick example. Say 4 people dine out with these frequencies 2, 4, 4 and 6 times in a month. The mean or average is easy to calculate. So 2 plus 4 plus 4 plus 6 divided by 4 gives us mean of 4. Now the variance here is 2, which is derived by using the formula of variance. So first you find the squared differences from the mean. So 2 minus 4 square is 4, 4 minus 4 square is 0, 4 minus 4 squared again 0, 6 minus 4 square is 4. And so you add them up, 4 plus 0 plus 0 plus 4 equals to 8. Divide by the number of data points, so 8 divided by 4 is 2. And the standard deviation is the square root of that, so roughly 1.41. Let's see how each value relates to the mean. The person who dined out 2 times is about 1 standard deviation below the mean. So that's within 1 sigma, because 4 minus 1.41 is 2.59, which is between 2 and 4. Someone who dined out 4 times is right at the mean, and the one who dined out 6 times is a little farther out, within 2 sigmas, but beyond 1 sigma, because 4 plus 1.41 is 5.41, which is less than 6. So we will cover these concepts in detail in our next video on normal distribution. So alright friends, I hope this video helped you understand mean, median, mode, variance and standard deviation clearly. If you found it useful, don't forget to like the video, leave a comment, sharing what you found most helpful, and subscribe to the channel for more such beginner friendly and practical content. See you in the next video. Until then, keep learning and keep growing.